This is problem number 45 out of the textbook. It says that a bowling ball of mass 7.3 kilograms and radius 9 centimeters rolls without slipping down a lane at 3.3 meters per second. Calculate its total kinetic energy. It's got two components of kinetic energy. It's got traditional translational kinetic energy, but it also has the rotational kinetic energy. Since this bowling ball can be treated as a sphere, rolling down here, this the fact that it's rolling means that it has its own aspect or component of kinetic energy. So I would write this out as the total kinetic energy in this problem is equal to the traditional kind of translational kinetic energy. I'll leave it without a subscript, plus the rotational kinetic energy due to the rolling of the sphere. That leaves me with 1/2 mv squared, which is pretty easy because I have both the mass and the velocity of the ball, plus 1/2 I omega squared, where I is the moment of inertia of the ball, and omega is the angular velocity. There are going to be two important substitutions to make. The first one might be more apparent than the second one. I need to make a substitution for the moment of inertia, and in this case it's going to be a sphere with an axis through the middle, which has a moment of 2/5 mr squared. But there's a second substitution that I need to make over here on this side, and that is the relationship between tangential velocity, or kind of that traditional translational velocity, being the product of the angular velocity in radians per second and the radius, omega r. Therefore, I can write angular velocity as the translational speed divided by the angular speed, omega. Oops, I made a mistake here. I'm not solving for r, I want to solve for omega. So therefore, I'm going to leave the omega on the right-hand side and divide both sides by r. Therefore, omega squared is going to be v squared over r squared. And it's this piece, this kind of last expression, that traditionally kind of gets substituted back into the rotational kinetic energy formula here. So look what happens now to this last term. This becomes plus 1/2, where I is 2/5, and it's going to be m times r squared times v squared over r squared. The r squareds cancel out, so the radius of the ball doesn't matter, and I need to multiply 2/5 and 1/2. It gives me 2/10. So everything else stays the same. This is still 1/2 mv squared. And by the way, I'm solving for the total kinetic energy of this rolling ball. But this expression kind of persists here, 1/2 mv squared, and then this becomes 2/10, and it's going to be mv squared. So now I have to essentially find a common denominator. It looks like I can change this to 10. I'll just leave this as a 10. That means I need to multiply this. This becomes 5/10. And so 5/10 plus 2/10 mv squared combines to give me 7/10 mv squared. And now I'm basically just ready to substitute. 7/10 times the mass of the bowling ball, which is 7.3 kilograms in this problem. And they gave me the speed. It was 3.3 meters per second. I have to remember to square that. Notice that they did give me a radius of 9 centimeters, but it doesn't work out. It doesn't become part of this problem. And so once I put that through my calculator, I get something on the order of about 56 joules. And that's my final answer for this problem.